Hi, in this video, we are going to go over skeletal line structures of alkanes. So skeletal line structures are another way to show a shorthand notation for alkanes. Condensed structures were one way, skeletal line structures are another. And skeletal line structures, carbon atoms is understood to exist wherever two lines join and at the end of a line. So if we look at this image, we see that in pentane, this is the skeletal line structure, and it is assumed that there's a carbon at every end and every bend. So wherever two lines meet and at the end. So there's 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5 carbons total. The carbon-hydrogen bonds are omitted, so they're not shown, but understood to be present so that carbon atoms have 4 bonds, because all carbon atoms have 4 bonds. We're just not writing our hydrogen bonds in there because it gets cluttered, and shorthand notation means that it can go faster, so we don't write our hydrogens in, but they're assumed to be there. Cycloalkanes are drawn as polygons where the number of sides is equal to the number of carbon atoms in the ring. So for example here, if we look at cyclohexane, we have 1, 2, 3, 4, 5, 6 carbons in this ring, which means we're going to make a hexagon. So we have 1, 2, 3, 4, 5, 6 carbons in this ring. We have a 6-sided ring, and it is assumed that there are hydrogens coming off of each of these. At each bend, there's a carbon. So at each one of these, there's a carbon. So a carbon at every bend and at every end. So for propane, we have, this is the Lewis structure, condensed structure. We have the CH3, CH2, CH3. Skeletal structure, we have a carbon atoms right here, 1, 2, and 3 at every end and every bend. Skeletal structures for ethane, so 2 is just a straight line. We have 1 carbon here, 1 carbon here. For propane, we have 1, 2, 3, then 1, 2, 3, 4. And then for this bottom one, we have it at every end and every bend, but then also at the ends of the branches too. So we have these branches or substituents. So remember, there's a carbon at each end of those as well. So for practice, we're going to write the skeletal line structures for butane and cyclobutane. So pause the video, work on it, and then when you're ready, come back. Okay, so for butane, we have 4 carbons. And remember, skeletal line structures are that zigzag conformation. So I'm going to just start doing a zigzag for 4. So 1, 2, 3, 4. I have 1, 2, 3, 4. And there are no branches on butane, so this is what butane looks like. Cyclobutane has 4 carbons in it, and cyclo means that we're going to have a polygon. So we're going to have a polygon that has 4 sides. So we have 1, 2, 3, 4. 4 carbons in here. This is cyclobutane. Looks like a square. Write the skeletal line formula for each alkane. So pause the video, and when you're ready, we can work on it together. Okay, so first thing that I'm going to do is I'm going to figure out how long this main branch or this main parent chain is and write my zigzag conformation. So I have 1, 2, 3, 4, 5, 6, 7 carbons. So I'm going to write a 7 carbon zigzag. It's 1, 2, 3, 4, 5, 6, 7. I see on carbon 3 that I have 2 carbons coming off of it. So I'm going to do on carbon 3, I have 1, 2. This is 1, 2. So these are 2 additional carbons coming off of it. This carbon right here, the branching carbon, does not count because this branch in carbon is carbon 3. On carbon 4, I have a CH and two CH3s coming off this. So these are my CH3s, and my CH is in the middle. On carbon 6, I have one CH3 coming off. And you can see when I write this that the skeletal line formula that I'm putting my branches going off of the apex of the zigzag. So I'm not going the opposite way of the peak. I'm going off of the peak of the zigzag. Okay, so for this one, my main chain is 2 long, so I'm just going to write a dash because this is 1, 2. Off of carbon 1, I have 2 methyls. This is 1 methyl, 2 methyls. And then I have 2 methyls off of carbon 2 as well, so 1, 2. So this is a skeletal line structure of this compound. So in summary, in skeletal line structures, a zigzag array of bonds represents a chain of carbon atoms, and each point represents a carbon. Remember, carbon is at every end and every bend, and the hydrogens are not shown in skeletal line structures. They're assumed to be there so that every carbon has 4 bonds.